Hello everyone, welcome to this module Quantifiers and Predicates. This is Dr. K. Kalaiarasi, Assistant Professor, PG and Research Department of Mathematics, Kaveri College for Women, Trichy. Let us consider variables. It is a symbol that stands for an individual in a collection or set. For example, the variable x may stand for one of the days. Let x equal to Monday, x equal to Tuesday, etc. Now we use the letters at the end of the alphabet as variables such as x, y, z. So a collection of objects is called the domain of objects. For example, the days in a week is the domain of variable x. Now let us define quantifiers. So quantifiers are phrases that refers to given quantities such as for some or for all, for every. So indicating how many objects have a certain property. So two kinds of quantifiers are available. One is universal quantifier, for example for all, for each, for any, like this, and another one is existential quantifier. It represented by for some, there exists, there is for at least one, like that. Next, let us consider the definition of universal quantification of a predicate for all x p of x. Let us see the example. X must take a discrete mathematics course, that is p of x, and x is a computer science student, that is q of x. So now we can express the statement everybody must take a discrete mathematics course or be a computer science student. Similarly, we can see other examples. Now let us consider the definition of existential quantification of a predicate. There exists x p of x. So we consider the example of this. There exists x, there exists y p of x. So what is the meaning of this? So what universes of discourse make it true or false? So this is the corresponding truth values of quantifiers. So existential and universal quantifiers must have the statement true when and false when it should be there. So four type of statements are there. For all x, for all y, p of x, comma y. For all x, for there exists y, p of x, comma y. There exists x, for all y, p of x, comma y. There exists x, there exists y, p of x, comma y. Now we can express the statement there is a number x such that when it is added to any number, the result is that number, and if it is multiplied by any number, the result is x as a logical expression. So we can tell there exists x for all y, p of x, comma y and q of x, comma y. Now let us consider binding variables 1. So the expression there exists x for all y, p of x, comma y, both x and y are bound. For all x p of x, comma y, x is bound but y is free. So the statement is called a well-formed formula when all the variables are properly quantified. Now let us consider binding variables 2. There exists x for all y z, p of x, y, z, c. The scope of the existential quantifier is x, comma y. Now let us consider negation. So let p of x be the predicate, then the following conditions hold good. Negation of for all x p of x is equivalent to there exists x negation of p of x. Similarly, negation there exists x p of x is equivalent to for all x the negation of p of x. So a quantified version of De Morgan law is the universal of discourse is finite. It is exactly the De Morgan law. Now this is the truth values of negated quantifiers. Now let us consider the predicate in English. In English, the sentence has two parts, the subject and predicate. So predicate is the part of the sentence that states something about the subject. For example, in the sentence, John Cusack was in the movie Say Anything. John Cusack is the subject and was in the movie Say Anything is the predicate. Now let us consider the predicate in logic. In logic, a predicate is something that is affirmed or denied about the argument of the proposition. For example, in the proposition x was in the movie Say Anything, x is the argument, was in the movie Say Anything is the predicate. In the logic, however, the argument does not always correspond to the subject. Now let us consider the propositional functions prelude. Recall that a proposition is a statement that is either true or false. We can think a function as a black box which takes one or more inputs and produces a single output. For example, we can define the function square. It takes an input an integer x and output is x square x square. So the domain is a set of integers and the range is a set of positive integers. Now let us consider proportional function. So this is a function which takes one or more arguments, expresses a predicate involving the arguments, becomes a proposition when values are assigned to the arguments. So the domain must be defined so that the value of the proportional function is a proportional for every element of the domain. Next, consider the proportional function example. P of x equal to John Cusack was in the movie X. So P of x is not in the proposition since it is neither true nor false. However, P of the matrix John Cusack was in the movie the matrix is the proposition with a true value false. In fact, for any movie title, x P of x is either true or false. Therefore, P is a proportional function. Now let us consider the universe of discourse. So we know the universe is a particular sphere of interest, activity or experience. Is a discourse is written or spoken communication. Is a universe of discourse could be defined the set of all things we wish to talk about. For example, multiple argument examples. So we mentioned earlier the proportional functions can have more than one argument. P of x comma y, that means x was in the movie Y. So P of Kelvin backend the matrix, so we can write it as finally x is a set of all positive values. I hope you have understood this module. Thank you for watching.